Okay, welcome back. We will have a short lecture before we go to the hands-on.
Yes.
Kubilay, please take us ahead.
Okay. Hello everyone again. This is Kubilay. We will talk about executing a model, but before do that, I want to explain this approach or this example on flow chart. How we can do is, or how we are following which steps, something like that. Let's dive this flow chart. First thing first, we need to generate a OM model, as I mentioned before, or we can pick from our model zoo page. And is there different approach to manage memory management by the user or system? Of course, I can explain user side and system side, but we will just follow user side in this section because our hands-on about user management. And let's go next. Next box. Actually, if we follow user management, memory management, we will just obtain working memory size. You know, we will allocate a memory from MPU because you know why MPU and GPU is so important because GPU and or NPU is provides data parallelism or distributed training, something like that, and also you can pick more piece of data with MPUs or GPUs. And other thing is MPU and GPUs has own resources like RAM, like CPU, not CPU, but similar thing. That's why we need to allocate a memory from MPU RAM. That's why we are trying to learn our actual model size. After that, we passed MPU side. We will allocate memory according to this size, and then we will get a ID. Actually, this ID just how to say pointer ID because it's point RAM addresses on the MPU, and then we will push our model to MPU. And we will get a model ID and we will manage this model. Actually, I mean, after do that, we don't have a model on our host device. It is migrated to MPU, but we have this model's information. That's why we can manage it using ACL. That's why actually step by step we are understanding why we are using ACL. You know, if we don't have ACL, we have to use a lot of hexadecimal code to manage this memory allocation or memory size calculation, something like that, because low level language, but ACL provides high level functions. So let's move on. After collect model ID, hang on please. After collect model ID, we will follow a couple of steps, model loading, and we need to associate with MPU RAM, as I said before. So, but and at the same time, we will prepare input data for more inference. You know, we cannot put our image or maybe our data, because you know we can support computer vision examples, and also maybe speech detection, something like that. That's why we need to prepare our data before execute on our model. And after a couple of steps about model loading and data preparation, we will execute the model. But as you can see, there are two different methods on it. We will follow, this is synchron, maybe we cannot. Let me zoom in, maybe we can zoom in. Please try, control, where is control? No, maybe, okay, it's better, yes. Yes, there are two model execution. It's synchron and asynchron. As you can see, as you can understand, synchron means, for example, you have one MPU and it waits queue. For example, you have a work and you try to execute on it, and another have to wait this process. But if you can use asynchron inference, you don't need to wait this process. So, but asynchron inference a little bit hard to understand. That's why, and also we will follow synchron inference in our hands-on examples. So that's why I will go through on synchron inference. So we will follow synchron inference more, and since we will use it or hands-on examples, as I said, let's continue to follow next step on the chart step by step. After execution step, we will get model outputs and start to, as you can see, we will get model outputs, and we will start destroy the data step by step. You know, we allocate a memory from MPU side, and we give a model ID for this pointer, and that's why we need to destroy it after collect model output. If we don't do that, probably we cannot use next stage, because probably it shows memory leak. Yeah, it's must. Let's move on next page. And so yeah, I want to explain more closely input and output data preparation. So let's dive into input and output data preparation stage and examine chart. First thing first, we complete this stage previous page, but it was a module on that stage. Now we will see details of this module together. Maybe we can zoom on. Yeah, okay. Yes. First, we need to create a data. Yeah, I mean, you know, we will get our input data, and we cannot use directly this input data as our model. You know, we applied allocation for our model, and we will do same thing for our input datas. That means, as you can understand, we will do a whole process on MPUs, and CPU or other components just manage the process. They don't care, or they don't spend a lot of competing power. Just we push to MPU, and MPU do that for us. And after do that, you know, we will get output. But output now on the MPU, and we need to move, or we need to port this output our host device, and we will use a couple of high-level function from ACL side to collect this output, and then we will get this output using memory management system on the pointer, and then we will do a couple of post-processing stage, and we will put more. We will put our data on the input data, and that's it actually. Sorry. Okay, I think we can pass hands-on stage. Okay.
So to talk about the inference part. So
yes.
For my mind, there's a separation between this stage where we do the training, for example, on some slurm system or something like that, and then we prepare this model. We have this model output. This is some file. I can put it somewhere in an S3 bucket, and then I can mount it into my inference service. So,
yes.
So how does it work with common standards such as I want to say I have a predict protocol v2, which is supported by other vendors, by other platforms such as TensorFlow and Kubeflow, and use it to for container-based APIs for my model. Would that work with that solution that you just showed us?
Actually, good question. Do you mean how we can?
Okay, so the core question of this is I need some one time to execute this model.
Yes.
So what APIs does this one-time support?
I see.
I see. Put it into a container.
Yes. You can put it container directly. For example. Or you can use directly a high-level approach on our site, application site. For example, we have Minix Vision SDK, and you can put your data directly. Don't do anything, and you can collect your needs using just a JSON file, something like that.
Okay, so the idea is that I'm thinking about something like I want to offer AI as a service. So my users come to me, give me some model, okay, I put it into some bucket. They say what runtime they need, okay, I put it into a container. Now I can dynamically scale up how many containers should load this model and give them some API where they can submit their data and get an answer either synchronously or asynchronously, whatever they need. And so the idea is that I would support any kind of model that they give me. as long as I have one time that I can put in there to support that model. So
yeah. So actually, we don't have this kind of thing in our products, but you can do this using our infrastructure. For example, as I said, MyNextDL, something like that. But at the end of the day, you have to write some code to align your idea.
I think tomorrow we have a session on how to deploy such an AI inference on the edge using tools like SEDNA and KubeEdge. Probably it will be covered tomorrow.
okay. At least from my perspective, if I'm looking to the person, I would look for one of the major players such as Kubeflow, Kserve, which I think is still a bit better supported than SEDNA at the moment. So and since Kserve is so flexible, in the sense that you can put any gives them any runtime and they just use it internally. I was hoping
I think tomorrow you can get those answers tomorrow.
Should be able to work with that.
Yes. Obviously, you're not expert in
Yes,
edge.
I am not expert on edge. That's why
more of an AI.
I'm not sure how we can do it. But as I said, do you want to create asynchronous, synchronous maybe works, and I mean you want to create a scheduling, right?
At least in the use case I'm imagining right now, I would expose it as an HTTP or a gRPC API, and users can choose what they need.
Yes, actually, we can do it, but as I said, for example, we have a project about it, but it's so new project, and I mean in the theoretical side we can do use our tools and our infrastructure, but we need to put some codes, and we need to develop some infrastructure to provide this how to call it synchronization and asynchronization workload management. That's why maybe tomorrow he or she
both. I think we'll have a lecture on KubeEdge and SEDNA tomorrow. There's a hands-on where you will deploy a AI service and see how it scales. But I think to just answer the point, I think we have a Huawei cloud where we provide AI services.
Yes.
Actually, as well, inferencing and everything.
Yes.
But I think we are not the expert. At least I'm not expert.
Yeah, I'm not expert. But we have not. I mean, we are still trying to develop this kind of thing on our site. Actually, it's not new thing, but it needs to employ maybe next 3 years. In next 3 years, so you know, MPU is really new approach. So yes, maybe you can ask your question tomorrow again.
Okay. So it was, I think, like this predict protocol, which is used by NVIDIA Triton, inference, in TensorFlow serving, and Kserve. And so these are always the major systems that support it.
Yes.
So the question is, do you support it, or why do you not support it if it's such a major protocol in the market? But okay, we can talk about more tomorrow when we look into the deployment part.
Okay, okay. And yes, we can start hands-on. If any question,